Okay, friends, our subject now, capacitors and the capacitance, section 2. I will solve some question. Practice 7b1. 4 microfarad capacitor is connected to 12 volt battery. Capacitance is given. C is equal to 4 microfarad. And that is equal to 410 to minus 6 farad. And the second potential is given, delta V. Delta V is equal to 12.0 volt. And in A, it says that what is the charge on each plate capacitor? Q wanted. And B, it says if the same capacitor is used connected to 1.5 volt battery, how much electric potential energy is stored? Delta potential energy wanted if delta V is 1.5 volt, it says. So let's solve them. Firstly, A, charge wanted. Q is equal to C delta V, as we know, and then charge is equal to here, C given 410 to minus 6, multiply, potential is 12 volt, then charge will be here, 48, 10 to the power of minus 6 coulomb. We get charge. Then, what is wanted in B, question B, in part B, delta potential energy wanted. How can we calculate delta potential? Delta potential energy of a capacitor. If you remember, I said try to use most of these capacitance because it will be constant, but charge and potential can be changed. Here, what is the capacitance? It is given constant, so I can calculate it as 1 over 2 C multiply delta V square. Delta V square. Then delta potential energy will be 1 over 2, C is 410 to the power of minus 6, multiply, V is 1.5, remember here, potential 1.5, with the square of 1.5 volt. And potential energy here will be, if you use calculation, you will get 4.5, 10 to the power of 6, 4.5, 10 to the power of minus 6 joule. This is the first question. Second, the logic here generally the same. And second, a parallel capacitor has a charge of 6 microcoulomb. Now charge given, Q is equal to 6 microcoulomb, and we have to change it to coulomb. 6 10 micro, we know 10 to minus 6. 6 multiply 10 to the minus 6 coulomb. When it is charged by a potential difference of 1.25, delta V is given 1.25 volt. And A, it says find the capacitance. A, capacitance wanted. B, same as previous. How much potential energy? Delta potential energy wanted. If 1.5 used as again here it says, before we use 1.25 volt, now it says if delta V is 1.5 volt. Let's calculate them. First one, A, capacitance wanted. We learn capacitance is the charge divided by potential difference. So C is equal to, charge is given 610 to the power of minus 6, divided by delta V is 1.25. If you divide it, you will see that C is equal to 4.8 10 to the power of minus 6. 4.8 10 to the minus 6 farad, sorry. You get capacitance. Now we know capacitance, potential wanted now. Again, B is equal to the delta potential energy is equal to 1 over 2 C multiply square of delta V. Delta potential energy is equal to 1 over 2 multiply C, 4.8, 10 to the power of 4.8 here. Let me write clear. 4.8, 10 to the power of minus 6 multiply square of 1.5 volt. And delta PE, change in potential energy here will be, if you use your calculator, you will see that it is equal to 5.4 10 to the power of minus 6 joule. A third question, again practice 7b, problem 3. Now a capacitor has a capacitance. Now capacitance is given, C is equal to 2.0 picofarad. If you don't know pico is 10 to 12, so I will write it as 2 multiplied 10 to the power of 12 minus 12 farad. And then what potential difference would be required to store 18 picocoulomb charge? Q is given. Q it says 18.0 picocoulomb. Again, instead of pico, I will convert it to coulomb. It is equal to 18. 10 to the power of minus 12 coulomb, and in A it says potential wanted, potential difference. B, how much charge is stored when the potential is 2.5. Q is wanted, but it says if delta potential now is 2.5 volt. Let's do A, it's easy. Delta V wanted. Delta V is equal to, remember C is equal to Q over V, so V is equal to here, Q over C. And delta V is equal to, charge is given, 18, 10 to the power of minus 12 coulomb, divided by 2, 10 to the power of 12 farad. Then 10 to the power of 12 cancel to each other. Delta V will be here, 9 volt. B. It says what is the charge stored. Since the capacitance of the capacitor are constant, in order to calculate charge here, I will say Q is equal to now, C is constant, multiply delta V2 now. The delta V2 here, 2.5. It's not the potential we used before. Potential change, it says. So Q is equal to, C is given, C constant, 210 to the 12, 210 to the minus 12 farad, multiply 2.5 volt. Then when we multiply it, we will get charge as 5 multiplied 10 to the minus 12 coulomb. That's question 3, and the last one from practice B7b. You are asked to design a fireplate capacitor having a capacitance of 1 farad. C is given, C is equal to 1 farad. And then the plate separation D here 1 millimeter, plate separation given 1 millimeter, we have to change it to meter, it is 1, 10 to the minus 3 meter. Calculate the required surface. A. Gentlemen, when we construct or design a capacitor, we know that here we use epsilon 0 and it is 8.85 10 to the power of 12 minus 12 clone square multiply and so divided by Newton meter square area wanted. And C is equal to capacitance epsilon A over D. You know it, epsilon A over D. What is wanted here? A wanted. When we cross multiply, we will see that A is equal to C multiply D over epsilon 0. Then A is equal to C is given 8.85 10 to the power of minus 12 multiply D. Oh, sorry, I made a mistake. C is given, C is 1 farad multiply. Distance is 110 to the minus 3 meters divided by 8.85 10 to the minus 12. So from this equation, A will be, with your calculator please, you will get that A is 1.13 10 to the power 8 10 to the 8 meters square. It's very huge area, but anyway, it's asking our book. Area is 1.13 10 to 8 meters square. Thank you guys.